Hi everybody. It's together. The beast is together. And what we found was where we were going to use, I ended up popping out two of the collar bolts, and then these two bolts go right through the entire rotor. And only one set screw is used on each of the two couplings, and these nuts on the end here will be tightened down tight, and that'll bind the whole thing up. These rods right here are for the final alignment on these on the coil structures, and we've got spacing. The spacers, the way we did the spacers was interesting. We were going to use nuts and washers, but what we found out was if we use a wider washer, we can stack these washers 4, 5, or 6 and put them on these two bolts and then slide the rotor against the next coupling. So it goes from coupling to the rotor, coupling, rotor, coupling, rotor, coupling, rotor, all the way down through. And you use these washers as spacers to get the right distance between the coils and the magnets. And we're a little off. Some of it's wider than others, and whatever. And but we had to, because some of the glue on the coils is sticking up 1/16 of an inch or so, so we have to give it some space to play with. And down here in the bottom, what we found out, we had to ream out some of these holes so that this adjustment here could slide back and forth, also pertaining to play with the distance between the coils and the rotors. And I guess tomorrow I'm going to finally finish up these guys with all the nuts and bolts. These are the tensioners that actually adjust to the fine adjustment, and I have to add some pieces on here down to the base plate and screw into these, because of the way this thing is. It's sort of like it sort of moves, the whole thing moves back and forth. And but believe me, this thing is heavy. It's it's got to be way over 120, 130 pounds. Two of us moved it around some, but we're gaining. And next step will be the copper disc, and I'll just take you a walk over the top here, show you what it looks like from the top view. This rotor has no magnets on this side. I can put epoxy some on. The balancing was interesting. We ended up using the washers with the goop in certain areas. This one needed 1 penny, and that's where the 1 penny adjustment ended up being, was the washer right there to balance it. So, and then on the top we've got the same thing I described before. You got the even side, the odd side, pickup and power, and so we're ready to drive this beast. And so we're getting the only thing left is after I get the LED sensor thing built, would be to use this. This is a Tesla coil arrangement here that I use on my multi-wave oscillator, which is also on the YouTube videos, and uses a battery and a variac right here, and it uses an inverter. It's got a neon sign transformer back there, voltmeter, ammeter, spark gaps adjustable, puts out either normal electricity or cold electricity, whatever you want to design in. And that's going to go with all this crap that's piled up over here. In here's my Barker Williamson coils buried in there, and the caps. So all that's got to come out and be redone. The two PC boards up there on the top shelf, those are all totally completed but not tested, and that's a new design with all the incorporated errors that were made on these boards down here. These actually do work. They ran the prototype, which is on the Don Smith number 39 video, and so I got to put that LED sensor back on there and get that thing back up and running. That's probably going to be in a museum someday. Anyway, have a great day.